Hi everyone, thank you for your patience. So my name is Justin, and as Florida mentioned, I work at MongoDB on our cloud products. But I'm not here today to talk to you about databases. I'm here to talk about music and data streams. But if you indulge me, I'd just like to start with a short story about how I got here and where this talk came from. So the day before I turned 21, I loaded up my bicycle with 2 bags at the front, 2 at the back, sleeping bag, a tent, and a 12-string guitar, and I took off across Australia. I'd been really burned out by programming. I was privileged enough to study computer science, and I'd actually been working in Sydney back in the dot-com boom of Cold Fusion, of all things, and I just totally needed to get away. I felt that computers weren't real, that being inside wasn't right, and I just needed something of substance. So I just took off and rode my bicycle. And when I was out there, the one thing that really kept me company and kept me going was my guitar, was this music thing that I had. And I'd busk along the way, and I performed at restaurants and hotels, and I swapped playing for food and board, and sometimes I'd just be out camping, and it was what kept me going. So much so that when I came back to Sydney about 4 months later, I really wanted to do something different, and I wanted to study music. So I decided I'm going to be a classical guitarist. What better way to learn to play guitar than to learn classical? So I learned to read music, I got a teacher, I just dived headfirst, and I applied to conservatorium and managed to get in. So here I was, this self-trained classical guitarist surrounded by all these dyed-in-the-wool classical performers, and I was way out of my depth. And the one solace that I had was Western music theory. Western music theory just made so much sense to me. Scales, octaves, harmonics, chords, progressions, modes, it all just clicked in my head, and I just loved it. It was the one thing that kept me going. So at the end of my degree, I was faced with this decision. Do I continue the classical guitarist route, which is refining works from the classical repertoire? Do I keep going on as a composer and bother choirs, conductors, orchestras to play my works? Or do I go the third route and go into academia and work on my art in the background? And when I thought about all these options, it really became obvious to me that what I wanted to do was creative, but I couldn't be that person that was hassling the conductors and choirs. So I decided to scratch it and to go back into programming. And I actually found that there was plenty of creativity in programming, as I'm sure many of you know. You can be as creative as you want to be. Just because you're inside doesn't limit you. I obviously delved into the web, into UI. That is more my flavor of things. But I found a lot of passion. I could get back into it. And I guess I had to put music back on the back burner. So fast forward to today, and I've been in New York for about 6 years, and I've seen many fantastic passion talks around the many borough JSs, and I've seen many people share a lot of their loves and a lot of their passions and how they've managed to mix them with programming. And it's really inspired me to try to find a way to combine programming with music. And I think I've found a way today, and I'd like to share it with you a little bit today. But first, I need to talk about a couple of things. So the first thing is functional programming, FP. Now, I'm sure many of you are well aware of what functional programming is. A little refresher if you're not. It's really made a big resurgence in the last, say, 20 years. Haskell's come back in vogue. We have things like Elm and Erlang and a reason from Facebook. And very much it's a response to the unpredictability of object-oriented programming. We've also seen, I'm sure many of you know, that most imperative languages now have support for high-order functions. Go, Swift, Rust, JavaScript, Python, you name it. They all support higher-order functions. Even Java 8 supports them now. And in functional programming, as I'm sure many of you know, that we generally want to use arrays or collections of values, because a collection can contain no elements, it can contain one element, or it can contain n elements. And then we can do fun things to it, as many of you know, such as map, filter, reduce, and other functional composition operators. Now, at the same time, we've seen this move into asynchronous applications. I'm sure we're at a Node conference, so everyone knows much about async. But we've seen this move away from desktop applications into web applications, client, server, request, response. We've also seen CPUs get to their limit, and we have to scale horizontally. And we have to find systems that can handle sending data between different systems at the same time. Now, in Node, as I'm sure many of you know, we have a few different ways to do that. So I'm going to jump to this REPL here, and I might pump up the text a little. How's this? Does that look pretty good? OK. So one of the most common patterns, obviously, we're all aware of callbacks, and we just heard a little bit more about callbacks. But one of the most common patterns to get data over time might be what is called the event emitter, or we can think of as a publisher-subscriber. Now, the publisher-subscriber model is great. It's pretty straightforward. There is one major limitation, though, which is that if somebody emits an event before anyone listens to it, it's a little bit like a tree falling in the woods. You won't get that. You won't get that event. So how do we improve on that? Well, many of you no doubt know that we have promises, and we just heard a bit about those as well. Now, promises are somewhat new to Node, but they basically solve that problem in that if I ask for data, if it's ready, I'll get it immediately, and if it isn't, well, I'll get it whenever it happens to be. But again, this is Node, so I think we can still do better than this. So let's have a look at streams. So stream is a similar idea. It's more made for input-output, but let's play with it here. Let's go away from input-output and just think of it as a way of getting data over time. In this simple example, I have the word empire, and I'm just going to emit character by character out to the screen. So if I assign that to a variable, I'm using var for those who are watching, because if I make a mistake, var is very easy to override, and I'm commaing undefined so I don't pollute up this REPL. So if I pipe this to standard out, then you see the word empire written at the bottom. It's great. Limitation, though, is that it's a pipe, it's a stream. We've taken everything that was to be read, and we've sent it to something that can read it. So if I try it again, there's nothing left, which is, I guess, as you'd expect, the data's been read. Makes sense, right? OK, so that's Node. That's a little bit about streams. So where does this lead us? So it's all got me to thinking about music and what music really is. And it seems obvious to me, or it seems aware to me over time, that music really is just data. If you look at this piece of music, it's a piano piece. There's the left and right hand is treble and bass clef. And what we're really looking at is pitches over time, and the little strokes denote the rhythm. And the more I sort of thought about FP and async data flows and music, I realized that they really are one and the same, and that maybe we can use functional composition to play with this idea of what music really is. If we think about something like a major scale, right? Well, really all I'm doing is I'm projecting semitones from one starting point to the other. If I change the key, it's the same formula. I found that fascinating. And what I also found fascinating is if I filter out notes from there, if I filter out the first, the third, and the fifth, and then the fourth, the sixth, the first, the fifth, seventh, second, I get a chord progression. I always found that really so fascinating. So I'd like to introduce you to Node Keyboard. It's a little tool that I've written that superpowers a REPL with Western classical music and allows us to play with functional programming, data streams, and classical music. And I think it's really kind of fun. It uses a concept called sound fonts, and so we can change instruments on the fly and do all sorts of different things. So let me show you how it works. So first off, it's actually been running in the background. You might have seen me pop it up at the beginning. So let me just unpipe everything and restart. So the first thing is the MIDI in stream. Now, you might have noticed before, let me restart. You might have noticed before that I had a MIDI keyboard. So if I play some notes here on this MIDI keyboard, nothing happens. But because Node Keyboard's been started, it's a stream. So now we can take that stream and pipe it wherever we want. So we can pipe that to audio, and the chord comes out, as you expect. So it doesn't matter that it happened in the past. I get it absorbed and sent to me, and then I can keep playing as you'd expect. What we also do with this tool is if you don't have a Node keyboard, don't have a MIDI keyboard, we can do it just from regular notes. So I could do a C7 chord, and I could pipe that to audio. And let's see what happens. Now, this is going to be an infinite stream, so I'm going to stop it very, very quickly. It basically just repeats every note that it has in order. We can also do something where we could maybe pipe in the MIDI into a piano. Maybe we can pipe it to a logger. Those who are playing it on at home might notice that these streams that I'm piping to aren't exactly writable streams, they're actually duplex streams, so I can chain them on like this. But now I can actually do a little, which is a bit of fun. And little notes are highlighted. Cool. But let's have a little look at music theory now inside this little world that we have. So if I look at the C major scale, what it really is a simple little scale like this, C, D, E, F, G, A, B. It's the easiest scale we think of in major minor because it doesn't have any sharps or flats. The number after it just happens to be the octave in the piano. We can just ignore that for the moment. Now, as I said before, if I take that scale and I filter out the first, the third, and the fifth, I get the C major triad. If I filter this out to the fourth, the second, and the first, I get the fourth. I get the fifth. If the fifth, the second. You're hearing the most common chord progression in Western classical music. And what that progression really is, is this thing. It's just a collection of semitone intervals. So I go back to this piano and show you one more time. If you look at it, every step is considered one. So these are all just me moving up one semitone. So the pattern here is really just 2, 2, 1, 2, 2, 2, 1. So if I start at C, I go 2, 2, 1, 2, 2, 2, 1. And that's all a major scale is. It's nothing really that fancy. Now what I can do is I can play with this a little bit. So if I take that and I make it a sequence here, and I play it every 500 milliseconds, it's a major scale. What's really interesting is if I take this progression, I take the last semitone off, and I go to the beginning and I put it on the front of it. So taking the last notes, instead of 2, 2, 1, 2, 2, 2, 1, I take that one at the end and I put it at the front, and I play and I shift the progression so it becomes this, and then I play it one more time. We're hearing one of the 7 modes of music. This is the Locrian mode, probably the least used mode of all. But if I do it once more and play this to you, it's the natural minor scale. And I always found that so fascinating. The natural minor scale is just it's literally just shifting around this progression. That's all it is. Now, before we leave the Node keyboard environment, I want to show you one more example, which is some of the fun things we can do with this. So with streams, because Node keyboards all built on streams, we can take a couple of things. We can put 2 streams together and if we sort of play them simultaneously. So if I take a C major triad, I pipe it through a delayer here, and I pipe it through a banjo, and then I say audio it. And at the same time, I take the MIDI in and I delay it. I pipe that to the audio and a piano. We can maybe have a bit of fun. Let me pull this up as well. Cool, I made it. Thanks. So that's a Node keyboard. It's a little bit of fun, but I actually, have a confession to make. Part of the reason I created this tool was because I really wanted to dive deeper into things like streams. And there was another library that I've been using on and off over the years that I wanted Node keyboard to help me oralize, if you will. So Streams are all well and good, but what happens when you want to start putting them together? What if you want to start using functional composition to do something a little bit more than just transforming them? Now, there's a library in Node called Highland.js that actually does this very nicely with Node streams, but I'm going to talk to you about an alternative, which many of you, well, few of you at least would have heard of, which is called reactive extensions. Now, reactive extensions is also called RX, came out of Microsoft about 15 or so years ago. And for them, it was out of their .NET labs, and it came with C# and Link, but it's really gone quite cross-platform since then. The most notable company that uses it these days is Netflix. So if you ever hear anyone from Netflix talk, you'll probably hear them mention RX. And it is not to be confused with React. It is a completely different cross-platform framework. And I've often found that RX can be very convoluted. It's full of all these operators, and it's always really hard to understand what to use in what situation. And so I wanted to use this tool to sort of help me disambiguate some of these confusing operators that exist. So what you often see when you go into RX is something like this. So what this is called a marble diagram. If time is on the horizontal axis, then you'll have, and you had two streams, in this case observables, but we'll get to that, and we concatenated them together. And this particular operator would ensure that the first 3 events from the first stream occurred, and then when it ended, the next 2 events would come afterwards. This is marble diagrams, and they're not a bad way to visualize how you can use functional composition to take events over time and put them together. Because what RX really is an implementation of the observable pattern. It's sort of like a superpowered publisher-subscriber, because it takes away just the idea of a publisher and a subscriber and turns it into an observable and an observer, and that's a very powerful interface. So what does it look like? So let's jump back into here and let's have a little look and see what we can see. I'm going to run it again. Okay, so here's an inversion of that Empire little example before. I have a second example afterwards I've commented out, but I want to show you just the main way of doing it. As I said, RX, there's many, many, many different ways to perform the same operation. So if I were to instantiate this, and then I was to subscribe to it, because in RX we use this concept to subscribe, then you see the word Empire written out as before. What makes this very different from streams immediately is if I subscribe again to the same instance, I get it written. And this is one of the really interesting principles of RX, is they have this differentiation between what they call hot and cold observables. Now, what we think of as a hot observable, most of us would think of as before with Node streams. It's like watching a live television show. Someone is producing something and people chime in, and people subscribe in and say, I want to watch this immediately. What RX does is it just distinguishes between the two, and by default actually gives you a cold one, a rerun. So every time you attach a subscriber, they're getting their own events played at them. And it can be quite a useful paradigm. So what about with music? How might this work with music? So let's dive a little deeper. So let's have a look at some examples here. So what if I were to say, I want to project out? So what if I were to use the flat map operator, which many of you might recognize is a regular functional programming operator? I might take a note and then add on a CGC as well, and add that. What might that look like or sound like? So as I play notes, it's a little bit of fun. Now, there's another operator called the scan operator, and that's very much like a reduce. And what we can do here is we can take the last note that I played and play it again with the current note. So I could do some fun things such as play thirds if I wanted to. So if I were to run this, put the keyboard back up. It's a little bit of fun, right? You can do a little bit with RX. But where it gets really interesting is when we can start to sort of superpower it, if you will. Now here's a bit more of a convoluted example, but I'd like to show you a little bit more about modes, as I mentioned before. And modes in music can be quite a confusing topic. So I created this little RX stream that's a bit convoluted, but what it basically does is it will play out any modes for any chord, any key. So if I chose the key of G and kicked it off, it plays a G major, which is the Ionian. Then it goes to the Dorian, the Phrygian, the Lydian, the Mixolydian, the Aeolian, and Locrian. Basically, it's just taking that projection, that 221, 2221, and shifting it one by one. And that's what modes are. So, that is a lot of fun. But it led me to sort of this next question is, well, what about the other way around? What could we make data sound like? What could it sound like in which situations? So let's have a little look. So I want to show you this little example here. What if we were to use the mouse? What if we were to use the mouse and say, what is the screen resolution here? I think it's 25, 28, 7, okay, great. Good. So if we were to take the mouse and we were to scale the position of the mouse and take an events by it and do music with it, what could we do? So let's say we did something like this. What if every time I moved my mouse up, what if the pitch dropped? And if I move down, it goes up. Now what if I moved it to the right and I throttled the notes? It's a little bit like a debounce. I basically prevent too many events coming in at once. And if I move the other way, kicks right up. Ooh. If any of you know 12-tone serialism from the 20th century, this is really, really fun. It reminds me just of that. Okay, I gotta stop. So this led me to thinking a bit more about what if we were to do something else? What if we were to take Twitter and play with that? So what if we were to take the tweet stream of anyone who said the words Bieber, from anyone who has at least 500 followers, and what if we were to put it through some static sentiment analysis? Now I've piped this through some tracking, so hopefully I'm pretty sure no profanity will come out here. But if we just take this and see what happens, let's roll the dice. So every time a basic no positive or no negative, you just hear the middle C, and if we hear positive, it goes up, and if we hear negative, it goes down. There's one fan. Okay, I'm gonna kill all that off. So, what about elections? So it is election season, and tomorrow there is a big election. Now, I've actually tried this with anything less than 10,000 followers. So anyone who says the word Clinton with less than 10,000 followers, it gets really, really, really noisy. So I've limited it to 10,000 people. So 10,000, someone with at least 10,000 followers has said the word Clinton. We're going to map it through a guitar. We're not going to put the words on the screen. We're just going to make the notes, and we're going to play it out. So what does that sound like? Now what if, because we can, we would have changed this to a rock organ, and we would add on your friend and mine, Trump. It's the sound of the election. Awesome, thank you. So what else could be possible? Well, I mean, it really made me start thinking about the sentiment in tweet streams and Facebook, and there's been a lot of talk about that lately, about how Facebook has very much become like some sort of echo chamber. And it'd be interesting to come home one day and ask, say, Alexa, and say, hey, Alexa, can you play me my tweet stream, or can you play me my Facebook feed, and see what energies you're being exposed to every day. So what I want to leave you with is this idea that music really is just data across time. I feel like my journey has finally come back to some sort of completion, and I've managed to mix music theory and programming together, and I just want to thank everyone for letting me have this opportunity. This is the end of my talk, but again, thank you so much. I hope you've been as inspired by this community as I have. And I want to thank the organizers for this conference, because it really does take a lot of work and they put in a lot of hours. So thank you all.